Right, working on the 64K RAM card today. As you remember, it was supplied empty, there's no RAM chips in it. What I'd like to do is retain the two 16K cards, because they seem quite efficient, and then just fill in the remaining 32K with this board. I think that's possible because the banks seem to be separately addressable. Obviously you can't just take out 32K of RAM from a 64K board, because if you do that, even though there's no RAM there, if the decoding is not correct, then you can bring the data bus onto the system even with no RAM in it, which was obviously fairly disastrous. There's a couple of options. The RAM that should be in it is these, which are Intel, what are they, 2117s, and you can use these, which are 4116 RAM chips. They're functionally identical, and I'm going to use these for the initial testing. The problem with these is they're absolutely notorious for going short. So before you sort of use second-hand 4116s, you should really test them. I've got a little tester here, I'll show you that a little bit later. I have had this board loaded up and with RAM in a couple of banks, and I have had it in the system. You might remember a couple of videos back I tested all the boards along with this one, and this one seemed fine. However, as soon as I plugged this into the MDS, something seemed to be wrong straight away. The run light didn't even flicker on, let alone come on solid. Switched it off fairly quickly, and it appears that we now have a complete dead short on the 12 volt line. If I get the meter across the 12 volt, you'll see complete short. Initially I thought, well, even though I've tested the RAM, one of them's gone short anyway, but as you can see, I've removed all the RAM chips and we've still got a short. That sort of leaves us with a couple of possibilities. There's a capacitor here and another capacitor here, and they're across the 12 volt. I'm kind of leaning towards this capacitor here, because that seems to have the lowest resistance, so I sort of turn that round, stick the meter on it again. Shot. Right, here we go. Oop. I can't get a decent connection on it now. There you go, it's really, really low, as you saw then when the probe actually stayed on. I can't get a decent connection, but there you go. See, it's very, very low, and that's actually lower than it is here if I check it here. But it's all a bit marginal, so it may not be that capacitor. Had this been a new board, I would have just desoldered it one end and pulled it up. The trouble with these boards is they seem to be very delicate. That's not always a good idea. It seems to be better to actually desolder from the area with the most copper on it. Another worry as well is I think this is a multi-layer board, or it certainly looks like one, so the problem, the actual short, could be in the multi-layer, which is even more of a worry. So anyway, I'm going to cut this now, and then we'll see see if I'm right. So let's give that a go. Right, let's cut that one away. Let's see if that's made any difference. Back round again. Hopefully the short's gone, or maybe not. Ah, look at that. Well, that's cleared the short. That's an incredible relief. So at least we know it's not on the multi-layer part of the board. I was a bit concerned that possibly where I've been pushing down on the sockets to get the RAM chips in, that it may have disturb something in the centre of the board where the other layer is, and obviously that would be catastrophic really, because finding a short like that would be almost impossible. The worry now is, of course, if this one's blown up, then its little mate down here, which looks very similar, is probably going to head in the same direction. And there's a number of these on this board. There's one there, and there's another two here, which are concerning, because as I say, if one's gone, it's highly likely the other one's going to go as well. What I'll do, I'll have a look round and see if I can find something to put in this at least, and then we'll test power it up again and see what happens. Right, I've got the board back in the system and it's now running again, as you can probably hear from the rattling fan noise in the background. I've had to remove the capacitor down here, the other 12 volt one. That went dead short as soon as I powered it up, as predicted. We have got all the other voltages back now, so I'll show you those. Let's get the meter over. The one that was the biggest problem was the 12 volt, so we've now got our 12 volt back. We've got -5 up here, and we've got +5 down here somewhere. Where's he gone? There he is. Right, okay, so it is there. The other good sign as well, the row and column selects are running. If we look at that's the row select, that's 4, and column select's on 15, which is there. Obviously it's dynamic RAM, so that column and row select are effectively refreshing the RAM. I did want to show you the decoding circuit, but unfortunately it's not working. It did work for about 10 minutes and then it stopped. I've sort of gone through, I think it's about 3 schematic sheets, and sort of worked my way back from the enable and the data buffer back here on A98 pin 1, and it's gone through 1, 2, 3, 4, 5 ICs, and what seems to be happening is this triple input AND gate at the end here isn't working. Basically this output on pin 6 is permanently low. These two inputs are currently high, I'll show you in a second, and this one will pulse when the RAM's selected. So let's have a look at that and see what we've got. So the IC in question is this one here. So on 4 should, yeah, you can just see that's high, 5's high, there we go, that's high, but pin 6 is just low at the moment. Pin 3, if I can lean across the, let me just check that's in there. Alright, if I lean across to the keyboard, as I select the RAM address, you should see the probe flash. Right, so in theory, if all those lines go high, being an AND gate, we should get a 1 at the output, which is on pin 6. Right, I'll reach across the keyboard again. Right, I'm accessing that RAM and nothing's happening. So that's what's stopping all of the decoding logic working. I had a look at this IC, and you'll notice that just above it is where the capacitor was, and all the way down the side of this IC is corrosion, and worse still, this little decoupling capacitor here just to the right of it, on the other side of the board, the two legs of it have started to go blue, and on close inspection of the capacitor it seems to have had the last laugh, because it's been exuding its contents down its leg, down the board, and it looks like effectively it's rotted the legs away on this IC. I mean, they still look physically intact, but obviously some of the acidic goo or whatever that's come out of it has actually damaged the IC. So the next step is to cut this out and have a look. I'm a bit concerned as to what's going to be underneath it, but we'll see when we get it back on the bench. Right, I've replaced both the capacitors, this one here and that one there, and also the AND gate that was faulty. The decoding circuit's working perfectly now, as expected. I put the RAM back in, but unfortunately that isn't working. This board is designed to work in 8-bit and 16-bit systems, and the banks of RAM are sort of divided into an odd bank and an even bank. I'm not quite sure which one's which, but in a 16-bit system, the lower bank is fed off sort of data line 0 to 7, and the upper bank is fed off data lines 8 up to F. If you use it in an 8-bit system, the board uses something called a swap buffer, and that means that as A0 changes state, this bank over here is diverted onto the lower data bus, so you can read all of the RAM. Otherwise you'd only get half of it, of course. I had done a bit more probing and more reading of the manual, and it appears that swap buffer isn't working. I've traced it down to this IC here, which is a high-speed latch. I don't know if it will show up on camera. I'll show the end of it, but you may be able to see it. But the legs on it look a bit mouldy. It looks like the capacitor has struck yet again. And as you can see, that IC is in line with the other one that I've just replaced. And it seems to be much the same situation, that the output of this high-speed latch just is doing absolutely nothing. So I'm going to replace that next, and then we'll move on to the next bit of testing. Right, I've changed the high-speed latch now, and I think we've made a bit of progress. If I try and fill up a new area of RAM, 55 in there, I can display that RAM. That looks quite good. I can also do fill 1000 OFF with AA, which is just the bit shift. Display it again. Now, on the face of it, that looks quite encouraging, and I'm sure I could claim that I've actually repaired it at this point. But something rather interesting happens. You watch what happens when I try and alter the first 2 bytes here. So if I do substitute memory 8000, I'll put 01 in the first byte and 02 in the second byte. Now I'll redisplay it as I did before, and look what's happened. Every 128 bytes, as you can see here, it's repeated the two, the 0 and the 01 and the 02 we put in, which is really quite interesting. And exactly the same thing will happen if I do it here, just to prove a point. If I do substitute memory 80, and I put in 03 and 04, and I display it again, we've got, it's done exactly the same thing. You see now we've got 3 and 4 repeated every 128 bytes. Now this happens all the way up through the entire 32K. Thought about this quite a bit actually. You remember I said that the memory is sort of interleaved because it switches the 2 banks, so the odd bytes and the even bytes can actually be used on a 8-bit machine. That's why we're getting at least 2 accurate bytes here, and I've proved that because I've taken out a RAM chip out of each bank, and these figures do actually change, so it is actually swapping banks. So the repair, changing the high-speed latch that we've done to fix the swap buffer has definitely worked. Now we're getting the right data, that's fairly clear. What I think is happening is that we're looking at the same address over and over again. That's why we're getting the data repeated. Obviously it'll only happen every other byte because of the swapping effect. These two are swapped on A0 effectively. and if the swap buffer's working, then that means line A0 is working. But it does mean that anything over A0 up to A6, if I've got my little sort of rough drawing here, if you look here, that's 128 bytes from A0 up to A6. So effectively the address lines that we're concerned about are running from A1 to A6. Right, now if we have a look at the manual for that card, the first thing in line is this little, yet another actual high-speed latch, in actual fact, another 3404. You'll probably remember from, I think it was the couple of videos ago, I said the address bus was inverted on the MDS. That's what these slashes mean here. I think what they've done, they've used this high-speed latch not actually as a latch, because they've tied the write lines to ground, which effectively makes the latch transparent, as I understand it. But it's actually an inverting latch, so it's effectively turning an inverted A1 into an A1 that's non-inverted out on the other side of the latch. This is where I think the problem lies, and what I'll do, I'll reposition the camera now so we can actually see the board. We'll do a little bit of probing, and I'll show you what I've found. Right, back in front of the card now. One just quick note before I carry on. I was reading through the manual, and the MDS-800 employs a method called advanced write, unlike practically all of the other systems that Intel make. This means it asserts the write signal 500 nanoseconds before the address for that write is actually stable. And if that's the case, as it is in this case, obviously, you need to swap a little link, and that's this little link here. So that's obviously a significant thing you need to look out for. There's this entire board is absolutely covered in links. Can't really cover all of them. It's completely crazy. I've never seen so many links on one board. If anyone's interested in any particular links, then drop me a comment. Right, back to the matter in hand. The high-speed latch we're interested in is A82, which is this one here. Now what I'll do is I'll go on the input lines first. So pin 1 is the first, that's the first input, that's A1. See, that's flashing away quite happily. Now if I go to pin 2, you'll notice that absolutely nothing's happening whatsoever. And if I go to pin 3, which is A2, that's flashing away quite happily. Well, it would be if I could hold the probe on it. Okay, but if I go to 4, which is the output, again, it's completely just sort of sitting there doing nothing, and it looks like it's sort of tri-stated, in fact, so it's not high or low. Finally, I'll try pin 5, I think it's the next one. So 5's flashing, that'll be 8, no, that'll be A3, sorry. And it should come out on 6, and again, it's not doing anything at all. It looks just like it's tri-stated. I should check the actual right pin is low, which it is. So that's low, and the right pin from the other side is on 15. That again is low. So those in the output should be changing state, and they're not. This could well be the problem, of course. So I think this is going to be the next thing I'm going to have to try and change. Obviously this time it can't be anything to do with the capacitor, because the capacitor's up here, and the previous latch we changed was here, right down the bottom. So it's a little bit worrying that potentially these 3404 latches may be susceptible to damage over time. But anyway, we'll have to carry on now, and let's see what happens. I'll get this one changed out, and let's see what happens then. Right, I've got the new high-speed latch in, just there. So we'll give that a go in a couple of seconds. We'll put that out of the way. Right, I did promise you a look at my little RAM tester earlier, so we might as well do this at this point while we're on the bench. Quite simple, about £35 from JM Precision, designed by Jerry Walker. I'll just give you a quick run through on it. Get one of the little chips out, just a matter of popping him in, flipping him down. See if I can get closer. Right, when I press the button, keep an eye on the green LED. See it flashing away quite merrily. I'll do another one. It flashes every sort of cycle through, and if the red light comes on, it's failed basically. So it's a pass-fail tester. Right, it's well worth testing. As I said before. Well, these are actually actual genuine Intel 2117s. The 4116s are very similar, that I showed you earlier on, but the 4116 has got a really bad reputation for going short, and it really can do a hell of a lot of damage to your power supply and other chips around them. So £35 for something like this is a really good investment. You could do a lot of damage if you don't test them first, so always worth thinking about. Right, let's get back over to the MDS and try it out. Right, we're ready to go again. Machine's running again, as you can hear it running again. Let's fill up the block at 8000 again with something predictable first. So we'll do 1000 to 80FF, put it with FFs. Just have a quick look, make sure that's actually in there. Right, there you go, lots of Fs. Right, let's just fill up the first line or so. So substitute 8000, I'll put 01, 02, 03, 04, 05, 06, 07, that should be enough. Right, let's do display again. Right, there we go. Right, so it looks like we've actually got it working again. I've already preloaded my port-in monitor, which has got a test routine in it for memory. So what I'll do, I'll run that now. So 3800. Right, there we go. To test memory, we just type in T, where we want to start from, to where we want to finish. At the moment, we'll finish at 7FF. Or F7FF I should say, because obviously the monitor's at F800. Each time the little dot comes up, that's one completed cycle. Right, that seems to be working. Let's just pause that. And what I can do, because we're running a separate monitor here, I can actually turn the internal monitor off. So if I just reach over into the switch and flick it off, right, that's pulled the Intel monitor out of the system completely. Obviously we're still running. Now we should better test the whole memory range, so I can put in test 8000 right the way up to FFFF, which is the top of the 64K that the 8080 can address. Let's see how that goes. Right, it's 3 cycles through. What I'll do now, I'll leave this on test for a while and see how it goes. Potentially this may not be the only video about this card, but we'll see how it goes. Hopefully it'll be okay. Right, so everything's working now, so I shall see you next time.